So Jacek Laskowski, that's me. I'm IT freelancer specializing in Apache Spark, Delta Lake, and Kafka. So if you need me for anything and you don't, and you are not for Spark, Delta Lake, or Kafka, well, our conversation may be a little bit tricky to get right on track. But so just think about these three projects: Spark, Delta Lake, and Kafka, if you need to hire me. Okay, first. That's my main focus for the past 5 years, and I can't imagine any other day without them. You can contact me at Jacek@Japila.pl or just DM on Twitter at Jacek Laskowski. Okay, I'm best known by internals of online books available at this URL, https://books.japila.pl. And a few days ago, I started yet another writing journey where I'm describing my experience with exploring the depths internals of PySpark. I found it quite entertaining, especially looking at Python code from Java/Scala perspective. So yeah, that shows me different Spark. Definitely, I see all the collaboration between Python, PySpark, Py4j, and the core of Spark. So nice to see this extension and from the bottom. Okay, so that's about me. Friendly reminder, just as I said, if you've got any questions, just leave them in the chat window. But it might be that I will be able to answer these questions earlier. Definitely expect answers at the end of the talk. Okay, 2. Okay, Delta Lake. So homepage, Delta Lake IO. There are 2 versions of Delta Lake. One is open source, known as Delta Lake OSS, open source software. That's the aim of this talk. I've got no idea what's available in Databricks commercial Delta Lake version. I heard good stories about things like the order index, which is not available in OSS version, which you can find in Databricks. Quite recently, this is very important to note that a few days ago, Databricks announced that their platform is available on GCP. So now you are not locked to AWS or Azure. Now you can just use Databricks on GCP. I haven't tried it yet, but well, it's nice to see them on GCP. Somehow I'm more to GCP than the others. No idea why. Anyway. So what's Delta Lake? This is just a quote from the website, open source transactional storage layer over object stores. I hope during this presentation you see enough demos, enough examples to understand what they mean by saying open source transactional storage layer over object stores. You now understand why they say open source. Because, well, it is open source project, and transactional storage layer, it's coming over object stores. Well, in the cloud, object stores are the storage, so well, it's obvious that targeting object stores with something transactional may have some traction. And yeah, Delta Lake seem to attract a lot of attention. As I mentioned 2 hours ago, I had conversation with 10-ish group of people mostly from Poland, large organizations, banks, financial institutions, and they were all into Spark and Delta Lake. So yeah, that's nice to see this growing adoption. ACID transactions, yes, it is available as part of Delta Lake. That's basically what Delta Lake provides mainly. All other features, all other goodies, one may consider side effect of doing ACID transactions for Spark. So features like time travel. Well, if you are dealing with transactions, you may imagine some notion of versions of your underlying object store or storage. And that's what happens in Delta Lake. Delta Lake keeps track of all the versions transactionally or in transaction by transaction. And keeping track of all these versions gives you automatically this time travel feature. So you can just, for example, switch from latest version of your table or your Delta table to something that was available in the past. In version 08, they added support for streaming from the latest version of your table. So for some people more familiar with Kafka, it may seem like reading from Delta Lake is pretty much like reading from Kafka Topic. And yeah, I found it. I found this comparison very, how to say, very not attractive, but very correct for my understanding of Kafka, Delta Lake, and Spark. There is this feature of scalable metadata handling, because if you are dealing with transactions modifying underlying data and automatically moving to another version, you may expect, and it is available in Delta Lake, to have something like schema enforcement, making sure that your data match what's expected by shape, by column names, and by the types, as well as allow for something that's called schema evolution, something that you may have found in file formats like Avro, used for in Kafka-based solutions. So you've got all this as part of Delta Lake. So you've got schema enforcement, schema evolution, time travel or time traveling, and ACID transactions. What's nice about Delta Lake, and that was the main reason why I looked at, why I immersed into Delta Lake, was that its aim is to unify streaming and batch data processing in Apache Spark. This is just yet another data source or data format in Apache Spark. So for many people looking at Delta Lake, well, it just opens new doors to new features that are not available in Apache Spark, but because Delta Lake extends what's available in Spark by Spark compatible ways, well, it just kind of like part of the Spark. So for me, it was nice to open my understanding of what's possible in big data world without, joining high-priced college or universities that I probably would not be able to join because of my low rank or something. So I'm glad that big brains from Databricks, coined or created Spark and now Delta Lake, and let me learn from them by exploring the source code, because, well, it's all open source. Okay, so let's start with the first demo, where I'm introduce you to installing Delta Lake in your Spark application. By saying your Spark application, I mean Spark Shell, because I'm not gonna create a brand new Spark application. It would take too long for such a short meetup. So I just took Spark Shell. I'm gonna take Spark Shell and just extend it with Delta Lake. I'm gonna show what it takes to do this and what are the steps. Then I'm gonna create a Delta table. I'm still not convinced whether Delta table should be written lowercase or uppercase. Yeah, I know it doesn't really matter, but still, while I'm into writing, it's very important for me, or I pay attention to to details like this. But anytime I write Delta uppercase, it's like thinking about this Delta Airlines, even though it's not that popular in Europe. Yet, whenever I'm in US thinking about Delta, it's like, come on, Delta Lake or Delta Airlines? I'm digressing again. So, and then I'm gonna show how to read and write from to a delta table. Again, I'm gonna do this in batch using Spark SQL and in streaming using Spark Static Streaming. Okay, ready? Buckle up and let's see it in action. So let me, oops, okay, got it. So I lost my slides. Oh, come on, wait. Where are my notes? There should be, probably because I'm not doing this. Hold on. I apologize for this. Yeah, I now need to move it. Oh, come on. Why is it happening all the time? It looks like, regardless how long you may preparing yourself for presentation, something will fail, and it did already. Okay, we are back on track. So I've got my slides, notes, and you seeing my terminal, correct? Yeah, see people nodding their heads. Thank you. So first of all, let me prepare the ground because I may have done some presentations before. So just to make sure that everything is okay, I'm removing entire file system. No, I'm kidding. Well, every time I'm doing all these presentations, I'm thinking about using virtualized environments like Docker or Kubernetes. No, Docker would be enough, but I'm not that adventurous, and that definitely would not help that much. Just minus RF TMP delta should be fine, unless you make a mistake and you put a space between first slash and the rest. No matches, very good, because that's exactly what I expected, because I cleaned it up before our meetup, but just to make sure. Okay, I do this again. Okay, so what I did, first of all, I'm gonna use this location for all delta tables, okay? Except for delta tables that are going to be registered in this Hive-like metastore that's under Spark Warehouse and Metastore DB, okay? With DB log being logs of this relational database system that's behind this metastore underscore DB that supports this Spark warehouse. Okay, basically that's what happens, and that's why I remove it. Okay, so that's it. Now let me show you how to start, how to install Delta Lake. Well, it's as simple as any other Spark package. It just minus packages with these coordinates IO delta colon delta core underscore mind this Scala version to match. It has to match Scala version used by your Spark shell, by your Spark application, by your Spark environment, and then you specify 080 for the Delta Lake version. Then there are two configuration options that are very crucial for to tap the benefits of all benefits of Delta Lake. This is Spark Sql Extensions, and to inject all the Delta Lake goodies to Spark SQL to any Spark session created. This is just something that you can use to inject anything, well, not anything, inject extensions to make Spark SQL look completely different from what Spark SQL experts could expect or knew. So I warn you not to abuse you. Well, by definition, abusing is something bad. But be careful what you're doing while working with Spark SQL extensions, because, well, you've got full access to all the optimization layer, all the analysis phase, all the phases of your query execution. This is basically available through this Spark SQL extensions. This is crucial for Delta Lake to work properly with Spark, to interact properly with Spark, because of this second configuration option, which is Spark SQL catalog, Spark catalog. This is the name of the default catalog in Spark SQL. And by installing this extension, now you are telling Spark SQL to use Delta catalog to be the first whenever any table is looked up. So first it's checked whether it's a Delta table. And then if all is fine, well, Delta Lake and Delta catalog will pass it down the chain. Okay, so these two configuration options are crucial for your Delta Lake installation to be successful. Okay, so enter, and well, this is something that you may have seen already, unless you just started with Spark. And these warnings are because I'm using Java 11. And so, well, since Spark uses Spark, unsafe platform to keep all the data outside JVM, just to keep your garbage collector less busy. So our applications become faster. And some other things. So you will see this warning, but you can just disregard these warnings. And then loading, because we are using ---- packages. So all this loading happens here. I've got this downloaded already. So artifacts number attempted to be downloaded, well, 2, but none was really downloaded because it was already available, but definitely it was resolved. All is fine. Okay. Now, we are in Spark Shell. This is version 3.1.1, release candidate 3. I just built it for my, voting purposes, checking before I vote yes or no, non-binding. And so Scala 2.12. I did not attempt 2.13, even though partial support is available. It's on OpenJDK, 64-bit, Java 11. And that's pretty much it. Yeah, that's pretty much it. So that's about my environment. Now, I'm just checking my notes just to keep everything in shape. So let me start with creating a very basic Delta table. So it's as simple as this. Spark range. And for example, 02, which creates two record data set. Now I write it, and very important thing is that by default in Spark, Parquet is the default file format. We want to use Delta Lake, so we specify Delta as the default, as the data source to be used for saving our data set, our query, our result of our query. So format, and then the last but not least, save. Obvious, right? And Delta and 01, and that's pretty much it. If I typed all correctly, we should get this nice messages printed out to the console. And I did instruct Spark Shell to print out all these messages on purpose because, well, that's the purpose of our meetup, to learn more about Delta Lake, not from reading documentation, but by looking at the internals of Delta Lake and looking at what it can tell you by increasing log level or increasing, decreasing, depending on how you look at it. I definitely enabled all Delta related logs to all level. So we see everything that may ever get printed out by Delta Lake. So this is on info, so you will see it by default, because by default info is the default log level in Spark. And then you see something like creating initial snapshot. Well, we'll get to it without metadata because the directory is empty. That's true because we just started and we made sure that this directory is empty. And this is basically what would happen if we saved this as, if we had saved this as Parquet. So we basically added up with Parquet-like table with some extra metadata in JSON format. So for for some basic description of Delta Lake, you may easily and safely say it's Parquet plus JSON encoded metadata. Okay. Then, so this is Delta Log. This is the front end. This is programmatic API that you can use from your applications. If you want to go lower, below high level operators, and like format safe. And so Delta Log is responsible for managing, access to this extra directory we are going to look at in a sec. Then initial snapshot, let's skip it. Delta Log again, reporting us that no Delta Log found. Yeah, true, because, well, this directory was just empty. So it should come with no surprise. And you see that there is this mysterious directory _delta_log. As I mentioned, I just started exploring PySpark, and I know that underscores are special. It's underscores or dunders or specials in special characters or have special meanings for private values methods. So in this context, it's just to denote that this directory is managed by Delta Lake. So just as it is in, how do they say in English? They say something like putting horses before cart or something like this. There was something like this. There was the saying. So just as describing something that should be introduced later, I'm just going to say that delta_log is just extra directory that makes this directory no longer Parquet only. Okay, so you could read this directory as Parquet and it'd be fine. Let's do this, even though it was not supposed to do. It was not supposed to be done this way. But let's read format, be explicit that we are reading Parquet and load and TMP delta 01 and show, and I expect to see exactly what I saved. Range 02 gives me or gave me a 2 record data set. It was written as delta. So now your question could be, well, okay, so what's the point? Well, the point is that I showed you initial version, which is just a coincidence that version 0 of any delta table is basically Parquet table or Parquet data source or Parquet data directory. But that's where this similarity ends. Once you start modifying your delta table, you are adding features that are not supported by Parquet itself, not by this Parquet file format, but by this Parquet data source in Spark. Okay, so that's the beauty of Delta. Okay, so would things change if we did this? Whoops, sorry. Spark read format delta load, and now I'm gonna copy it. Same, you see? Well, except these two entries. Well, you could just disregard them, but they are telling you something about Delta, right? So there's this filtering files for query and done just to make your query faster, because basically it selects stuff from table. Okay, so now you've got all this, and there's this notion of snapshots of your tables because of multiple files sitting behind a particular version of your Delta table. Well, it'd be nice if there was a mechanism to keep this information handy, so future queries over this particular version of your Delta table were quicker than just scanning files over and over again. That's what this snapshot is for. It keeps track and all this information. It's a cached version of your delta table, and basically it's a snapshot of your delta table at a particular version. And what's more interesting is that we've got this, hold on, we've got this, oops, and we've got this console, right? And now you can see view, I know. And now you see, well, this is a brand new web UI from 3.1.1. And to be honest, I'm surprised to see, this UI revamped look and feel like, or wise. Look at this. This is smoother in a sense. It's definitely different. It's brighter. I don't know. Can describe it properly, but definitely it's different from what I got used to seeing in previous releases. Okay, and need to train my eyes to get accustomed to this coloring scheme. Okay, so under SQL, you see that you've got this show twice. Well, save. This is the very first query when I set this. Okay, let me do this so we can just. So when I did this, remember when I wrote this 2-row data format to this directory, we basically did this save and this save. Not sure why we've got two saves. One is for this, probably because we are local. This is local collection. That's why we've got this save here, because it's execute. This is command that was executed on the driver, because Spark range creates local relation. So basically, there is no distributed computation needed. So that's why you got this extra query. But why is it shown like this? Anyway, okay. So then you've got this save. This is the proper save. So whole stage code gen, range, it's basically reading and saving. And now look at this. You've got this delta and compute snapshot for version 0. I expected something different anyway. But then you've got this information that Delta Lake took the extra step to be ready with the latest version of Delta table you just saved, in case you need to read from it, in the same application. It's just assumption that it may be needed. Okay, and since the latest version is 0, well, we've got it snapshot. And just to prove my point that it's cached data lake table by RDD cache or data frame cache, you may switch to storage and see this delta table version here as RDD name, delta table state #0. This is the version, and this is the location of your delta table. Everything is cached, so nice. Size in memory, okay. So it's ready, one replicated, disk memory serialized. This is the default storage storage level, if I'm not mistaken. That's the name in data frame. And yeah, basically you can just look at it and 50 partitions, and yeah, you can just explore it. Okay, we are looking at the very bottom of what happens under the covers of this nice looking Spark range write format. Okay, then we did show and show. And there was this delta filtering files for query. Well, something we've seen already, but I'm surprised it's separate SQL query. Anyway, I think that they changed it. The last time I looked at it was 0.7. I haven't spent much time on 0.8 yet, and so I cannot answer whether it's something new in 0.8 or it was already available in 0.7. I don't remember it, having it seen. Okay, so that was how to install Delta Lake, and now create and So let's move on to reading and writing. Okay, even though we did something partial in this, space. Yeah. So review console logs. Reviewing console logs done, at least partially. We'll look at it again soon. And now let's have a look at this extra directory that was created. Something that we've seen is that's named by minus delta underscore log. So ls and tmp delta. And okay, this is the directory which we use to save our Parquet, well, not Parquet, Delta table. Okay, so as I showed you already, well, this is just basically Parquet data, Parquet data, data source. I don't know how to properly name it. But anyway, this is just definitely a data frame, data set. Data set. That's what I like the most. So this is Parquet data source, data set, 3 files. Fine. Okay. Now we've got this extra directory. Whenever you see this directory, this is in the top level directory of your Delta table. You immediately know that you are dealing with Delta Lake table. Okay, so whenever you see underscore Delta underscore log, know you are dealing with Delta Lake table. Okay, so let's have a look what's inside this Delta log, which, by the way, it's called transaction log. Okay, the very first time I saw this, it reminded me the days when I was looking at the sources of Kafka and how all the partitions were stored on disk. Kafka uses similar notation for the chunks. It's been a while since I worked with Kafka internals, so I'm not sure how they exactly name all the pieces, these chunks of data, but definitely they use a similar notation or format, okay? Then I realized it's similar in checkpointing or in other data sources. So basically, it's just a way to give enough space for all the versions that are possible in Delta Lake. And yeah, look at this. There are quite a few zeros, right? So this is 0 version. Then next version is going to be 000 blah 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 1.json 2 blah blah. And so I don't know what would happen if we name it 99999 and then just change this Delta table and attempted to save it as version, I don't know, billion or billions, whatever. So yeah, I've never tried it myself. Yeah, let me know if you did. So let's see what's inside. So look at this. This is commit info, some extra information that you may or may not have, with some extra information like timestamp, what operation created this transaction commit. It was batch write. All the streaming and batch operations have their names. So batch write is write. Then there are operation parameters like mode, error if not exists. This is the default save mode in Spark SQL. Partition by empty. We've used no partitions. Is blind append true? I'm not sure if I'm ready to explain this. So yeah, we'll see if you ask questions about what is blind append really for. Operation metrics, num files, so number of files written 3 or touched 3, num output bytes, and some extra information that you may also find in WebUI. Okay, but this is available in this JSON file. So if you are adventurous enough and you want to interact with Delta Lake by using this metastore, well, feel free to go and parse all these JSONs and just combine them together. And well, you have all you need. And then protocol, and that was changed a little bit in 08 because they added some extra information over this protocol. Can't remember what it was exactly. I just described it in my notes about Delta Lake, but it's been a couple of days, and so I simply forgot. Metadata, this is ID of the query, format, provider packet, which, by the way, is not changeable yet. Or there is a comment that fix me if it's gonna be ever possible. Some other options, schema string, something that you can use to understand what's the shape of this initial version. Partition columns, other configuration options, and created time, which, by the way, should be similar. Timestamp of this commit info is different from created time. Interesting. It might be because this metadata is about transaction when it was started, and this is when it was committed. It's possible, but I'm not sure about it. Okay, then these actions or actions section follows. So we've added 3 files. Just by looking at num files 3, we know that we are dealing with 3 files in this version. And now we know that these 3 files were all added. So they are brand new. And we've got the names. Okay, so now we can combine this information from this transaction log and use this to construct or reconstruct particular version of our Delta table. Well, this notion of version, even though I'm using it already for some time, you might not be familiar, what exactly is version in Delta Lake. It's coming, but still, just know that version is comprised of files, and these files has to be listed in this transaction log to be included. Otherwise, well, even though Parquet files may be inside this, Delta Lake directory, well, it's just coincidence that someone wrote files to this directory, but they are skipped and they just laying around and making some extra noise rather than something useful. Okay, so we've got this action add for operations that add data to our table. We have also opposite of add, which is remove, when we are for operations like delete. And there are some other actions. I think there are 7 actions, if I'm not mistaken. Okay, so any questions? Let me check where I can Q&A. Yeah, more chat. Yeah, okay, let me go over your questions. Might trigger some interesting information that I am supposed to share. Where are you? Blah, 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 blah. Where did you hear about the meetup? Greetings, meetup, Athens. Thank you, Delta Lake. Thank you, randomly watched. If you have any questions, welcome. Little off topic. Okay, a little off topic, but is Scala used much in production with Kafka, or is it Java? Oh, interesting question, which I found a little relation to our main topic, which is Delta Lake, right? But anyway, yeah, little off topic. So Scala, much production with Kafka? Not sure. I would consider Java because, well, Kafka decided to switch to Java-based API for backward compatibility, opening the doors to Java devs more widely, so to speak. Even Kafka Streams started with Java API before they added Scala API. So yeah, I'd not be surprised seeing more Java devs than Scala. How is performance metrics and consistency for ACID transaction? It's coming. Well, it's just optimistic transaction. So, well, if transaction managed to write this JSON file to transaction log, Well, it just won this race for saving files. So you will see some files being created and then recreated while transactions are retried. So if a particular transaction could not commit its changes, it will get retried. Okay. And then thanks for joining. We are recording, correct, Cheese. Will it possible to use these features of Delta Lake in Spark 2X versions? Interesting questions. I'd say no. As of Delta Lake 07, Spark 3 is required. They may loosen this requirement, but haven't heard they are interested in this. How fast is Delta Lake compared to Rdbms like Postgres? Well, fast. Well, I'd say, I don't know. Okay, let me put it this way. I've got no idea. We are speaking about different volumes, right? So that might be something that I'd say don't do that. Yeah, definitely. Thank you. Postgres could not, might have troubles with big large data sets. That's where I would not be surprised Postgres handled poorly, but overall other than that, no idea. Okay, so I leave it here. Okay, so let's move on, right? And so we reviewed our transaction log, and now let's read from our Spark table. Okay, Spark read format and delta and load and something that we've seen already, right? And show, okay, and false. Okay, is this what I wanted to show you? Delta, yep. So hop. This false is just truncate equals false. Okay, as a matter of fact, I don't need this. Okay, so we've got this. Okay, now a Spark table. Yeah, we did this already. So you just change it. Done. Okay, so no change at this point. Okay, so now, ladies and gentlemen, let me start another session. Shell Bach. Okay, so let's assume we have two Spark applications up and running. Okay, so this is our initial application, initial Spark Shell, and this is yet another Spark application, Spark Shell. Okay, now what I'm going to do is to import. Yeah, import, no, not this one, trigger. And the reason for this is that I'm gonna read using a streaming query and show you, how Spark Success Streaming deals or works with Delta tables, okay? So I'm using this trigger, and now okay, let me see if I can copy it. Yeah, I can. So why not do this rather than, yeah, oof. So what I'm gonna do is Spark read stream just to open, or just to open this declarative streaming way of describing my streaming computation, streaming distributed computation. I'm saying that my source is Delta Lake. I'm loading data from TMP Delta 01 directory. And then after I load it, after I created this initial starting point in my distributed acyclic graph, I write this stream creating endpoint for my data, and I'm using format console just to print out all the data I get from this Delta Lake table. Okay, and I'm doing it every 5 seconds. That was the reason why I imported this trigger. And that's pretty much it. So I start this streaming query. As you can see, loading version 0. In version 0.80, they added this extra option to read from latest version. So you can just skip whatever is available in Delta table, just pretty much like Kafka. Allows you to start reading from a particular offset. So you've got this batch 0 and 0, 1, exactly what you have here, okay? Minus ordering. Okay, and every 5 sec, you will see this checking the delta source, checks whether previous offset changed compared to current offset and whether there is something to be processed, okay? Okay, now I keep this running here, and now I'm gonna write some extra rows. Well, I append some rows like this. So Spark range 2, 4. So previously we had 0, 2. Now we add 2 extra rows. That's gonna be rows 2 and 3. Then write format delta. Make sure that you are including format delta, otherwise you will deal with exceptions that are far from delta related. Mode append, we are appending to existing table, and then, you know, the directory of our delta table, right? Right. So let's save it and let's see what's gonna happen here. Hop. So I saved these 2 rows, and look at this. We've got yet another batch here. And Spark success streaming or the streaming query will, you know, poll for new offsets and check every now and then, well, every 5 seconds, whether there are new records. That's basically what you may have experienced with Kafka too, right? So now look at this. Look at these logs. So let me show you these logs. So I'm saving 2 records, and now optimistic transaction started with table ID, which was something that was available in in this transaction log, attempting to commit version 1 with 4 actions with serializable isolation level. Loading version 1, okay. Version 1, I was supposed shouldn't be 0 anyway. So table compute snapshot, there is for version 1. Then there are some extra information like create a delta log file index. It's in JSON format with these extra files. Oh, now I got it. In Kafka, they call it segments for data or the files that hold data on disk. So segments seem very similar. Kafka segments seem very similar to this numbering scheme in transaction log. File size, extra information, snapshot, okay, some other information, and then you know, this transaction was attempted to be committed. It succeeded. It was okay. Committed delta #1 to file, and that's it. Okay. So let's have a look what's inside this directory again. So TMP delta 01. And now look at this. You've got now 6 files or so. It depends on your environment, number of CPUs and all this, okay? It doesn't really matter, okay? What matters is what's written here. Now you've got 2 versions. So without much, you know, working with, you know, Delta Lake API, whether it's in Scala, Java, Python, or SQL, you can quickly determine the versions available for your Delta table. And by looking at this 01, you know that you added 3 new files. So 3 new files now, 3 new files then for version 0, and you've got 6 files. These are the files. So guys, now the question, which I'm going to answer, by the way, but just to, you know, trigger some thinking. What's going to happen if I do this? Spark read format, Parquet, load TMP delta 01 and show. What's going to happen? What do you think? Let me see a chat window. Oh, there's Q&A too. That's all right now. Okay. Will not work. Nice. You will get all the files. Nice too. I'm thinking if there could be any other answer. Will it not work, or you will get all files? Okay, let's have a look. It's gonna work because we made sure that all versions are of the same shape, of the same schema. So Mark and Mitra were all okay, were all correct, but there were some assumptions to be made, before I could claim he or them could be right, okay, or correct. Okay, so yeah, but basically you can assume that everything would be fine because, well, delta table is Parquet. But that's not what we want to see, because now if we wanted to have a look at version, before the latest version, the one before the latest version of our delta table in Parquet, it's not possible. So there is no way you can know what was available before you got this version of your Parquet table. Moreover, this question, what was before this Parquet table, is kind of like meaningless. Well, because there is no notion of versions, right? It only makes sense to ask these questions for Delta Lake because, well, Delta Lake supports versioning. So, well, yeah, that's the beauty of Delta Lake, and that's the main reason, the main difference between Parquet and Delta Lake formats, even though they share much. Okay, so nice. So let's have a look. What's going to happen? Oh, let me read it again. What's going to happen if I change this format to Delta? And now I'm asking you, what's going to happen now? For different schemas. Pavel, is it possible to block reading Delta with Parquet? No, I don't think so. No, I think it's the default mode on Databricks. Really? Okay. To my understanding, to my knowledge of Spark and Delta Lake, I'd say it's not possible to limit what you can do with a particular data source while reading data from directory you've got access, you've got reading access to. So yeah, I can't think of a mechanism that would prevent you from doing this. So yeah, I think it's not possible to block reading Delta with Parquet. It'd be very nice to hear I'm wrong, because I could learn something from you. Oh, I think there is an option. Thank you, Pavel. Okay, Arin, for different schema, you will get all files from different schema. Arin, but not sure I understand this question for different schema. Actually, you get an error if you're trying to read it as a Parquet. Oh, really? Okay. Oh, yeah. If I've got different schemas for different versions of my Delta table, definitely I'll get an error. Okay, so guys, what's going to happen, folks? What's going to happen if I start to read this Spark read format Delta load? No, Victor. Nice, you stepped forward and gave us this answer, but apologize, it's not correct. it will work as previously. Nope, either, Pavel, but you can convert it to Parquet. Okay, look at this. What? Ah, jeez. I got confused by Spark streaming. Sorry. Okay. Anyway, that's the beauty of that's the beauty of live coding sessions where you think that you are right or you are the smartest. You forget about this. What smarter people than you say. Be careful. There are people smarter than you. You just neglect this fact, and now, yeah, it happens like this. Okay, yeah, you're right, because we appended, so that's why we got this same output. Okay, so streaming right. So look at this. We've got this, so I close this. Remember, we have this streaming read constantly running and checking every 5 seconds whether there's new data or not. And now let me do this. Okay, so I'm gonna check, and I'm gonna check. Okay, so this is important trigger, which I did already. And now I'm reading from format rate. Well, this is just built-in format. It could be Kafka. It could be any other data source you've got in your Spark application. I'm loading data from this format in a streaming fashion. So I'm creating streaming query over rate data source. I'm selecting values only because rate gives me values and timestamps. And I'm changing this value to ID. And then I write this stream in format delta every 5 seconds. Well, checkpoint location is required to this Delta Lake location. Okay, so now you know that we will have 2 streaming queries. One is writing, another is reading. This is reading, this is writing. So let's see what's going to happen. Hop. I did too. No idea why it happened. I know why. Because we started from, oh no, checkpoint location should be different. Interesting. I expected a little bit different results. Okay. Anyway, you probably did not notice, and you are not going to ask questions about this because, well, I could not understand. I could not explain it. So, okay. So what we see now? We see 2 streaming queries. One is select star from Delta table, which is here. Another is insert into. Okay, so we see that one is writing, another is reading. Now think about any other data source beside Delta Lake available for Spark that would make this possible. The only solution that comes to my mind are Iceberg or Hoodie. They are similar in nature of in features to Delta Lake, but since I've got no experience with these 2 others, I cannot claim whether they are better or worse in this or that. Okay, I only know Delta Lake and can help you with Delta Lake, but again, heard great stories about Hoodie and Iceberg, especially that there are some index-based optimizations, something that you may find in commercial version of Delta Lake, something that's not available in Delta Lake OSS. Okay. So yeah, so it's okay. So let me stop it. Yeah, is it something like this? Yeah, so let me stop it. Hop. Done. And well, after I stop this, well, nothing really nothing will ever be added again. So we'll get to this delta source checking whether there are new offsets available and whether there is something to be pulled from delta table. Okay. Now, before we switch to some other topics, let me do this. Let's review TMP delta 01 and see all the files. See, there are plenty of files. Some are for version 0, some are for version 1. Now it's tricky to get all these files assigned to appropriate versions, so right versions. That's why we have this transaction log with all these files, JSON files. Every now and then you've got this, every 10 files, you've got this Parquet file with checkpoint information based on these JSON files, 10 previous JSON files. It's configurable, so you can make this checkpoint earlier or later. By default, it's just every 10 files. And yeah, and what else? Last checkpoint. This is something I'm not sure. What is this? Version 20 size. How many files we have? 20. Because this is to mark the last checkpoint available, just to make looking up, checkpoint files faster. So if you need to recreate version 28, for example, rather than reading 28 JSON files, you know that you query a last checkpoint, you know that version 20 was last checkpointed. You read this file plus all these files, and now you've got version 28 of your delta table. That's basically it. Okay. The reason why it's so complex, or seemingly complex, is that it may happen in the cloud on HDFS-like file system, which is inherently slow or slow by design. It's not supposed to be fast. It's supposed to be fault tolerant, handling large large number of files, large number of large files. And so it may be slow. It might not necessarily be consistent. So all this information are supposed, plus indices that are built into Delta Lake, are supposed to give you faster access to your version data. Okay. Okay. Any questions? Q&A is. I see no Q&A window. And okay, let me check if it's hidden behind this. Okay, I'll check this later. Okay, there is something like format check enabled false. And what would it do? Okay, let's see. Spark shell. Come on. That's not what I meant to do, right? So --conf spark data bricks dot delta format check. I think I've seen it before, but can't remember. And you mean false or true? Okay, let me do this. And what is it supposed to do? Prevent reading delta table as Parquet? No. Format Parquet. Let's see. Yeah, it's okay. And let's see if this is set. Get. Let me check this. Oh my. So, yeah. Spark conf get. Yeah, and geez. Oh, yeah, false. So yeah, so Pavel, what is was supposed to do? Kafka. It will prohibit reading from packet when it's delta. No, look at this. It was okay, right? But it's for Databricks. Maybe. I don't know. Okay. As Stan stated about the default behaviors to throw an error, important format detected. A transaction log for data log was found. If you run, yeah, false, then you can. Okay, yeah, but I did this set false format check, maybe. But delta, this is only for delta. So, okay. Yeah, possible that it's possible. Possible that it's possible. Yeah. Okay. And so that's it for now. And let's go back to our slides. So let me, where are my slides here? Oh, it's here, Q&A. If you insert a duplicate of a record, are both versions duplicate 1 and duplicate 2 stored in Delta table? Or just one? If you insert, unless you do upsert, meaning if you find this record and then you update it, if not found, you insert it, then you will avoid this duplication. But other than that, you can just insert this as and have duplication, basically. There is no notion of index in database to prevent you from inserting duplicate data. And Delta Lake, yeah, I think Delta Lake does not hold you back from inserting whatever you want, as long as it matches schema. If you insert the same record every day for a year, do you store all instances of a record or just one? Well, it's basically a follow-up to your earlier question, right? I'd say there'll be 365 instances of the record. As a matter of fact, we can just give it a shot. I've never done it before, but okay, let's see. So Spark range 3, or we can do this just to make sure that, oh no, Spark range 3, right, format, delta, and save and TMP delta 01. Yep. Oh, now I'm surprised. Why is that? Jeez. Because I did not specify save mode. Yeah, it was only possible when I started, when I had, empty directory. So append or override. As a matter of fact, I can only append, right? I've always been confused by what's possible. There are save modes like override, append, and error if exist, and one more, if I'm not mistaken. But then, yeah, append. Well, by definition, append is append. So now you know what's going to happen. Okay, so we've got 3 new records. And then let me do this again. You will get extra 3 records. Yeah, and if you do this every 24 hours, well, basically you will get this 365 times in your Delta table. Okay. Yeah, we can do delete. Deletes. It's coming. Okay. So okay. So let's do the demo. Well, demo is finished. So now I'm gonna put this. Okay. So Delta, how much time do we have left? Chat.
We have so reserved for, yeah.
How much?
So basically, we have reserved for 2 hours. We still have like 40 minutes, something like that.
40 minutes. Okay, quarter. Okay, 50. You mean 30 or 15?
40.
Just checking. 40. Woo!
Yeah.
Nice. It's more than I expected. Thank you. Okay. So Delta Lake 08 is has just been released. Well, 23 days ago, but it's just almost like yesterday. Days are so similar these days, given this challenging times. Well, I'm hoping that you all are holding up well. So Delta Lake 080 released. Let's have a look what's possible, what's available, what it added. And that's how I marked my to check the links in my slides, so I don't have to remember where I should click and when. So yep. Oops, no, not yet. Okay, so what are the features they added? Okay, something that I haven't checked yet, and I've got really no, how to say, experience how important it is, the unlimited matched and non-matched. There are some optimizations, improvements in merge operation. So it supports schema evolution. Nice, nested columns. Yeah, sounds very nice to have. Merge into update. Nice too. Again, this is more about stacked columns, so nested columns. Check constraints. Yeah, they added two alter tables to add constraints or remove constraints on delta tables. I only roughly look at these changes, so can't comment on it. Why they're important yet know that it's available already. What I found very interesting, something that I really needed, it was to start streaming a table from a specific version. So now with this starting timestamp or starting version, you can just say, hey, I need to read this table using my streaming query from version 0 well, 0 is default, but from version, for example, 5, 5th or latest. They added this latest mnemonic or alias, so you can just skip everything that's available and, well, start as if you started from scratch. Yet, well, not from scratch, but from scratch would be from 0. So, well, from latest. Okay, let's stick to it. It's similar to offsets in Kafka. Well, yeah, sounds very important too. Yet haven't found time to dig into it. Ability to perform parallel deletes with vacuum, so you can just clean up files that are no longer available, no longer needed. And something that may ease your life as Scala developer. So after you import this implicit object, well, you get this nice extension, so you can just Spark read delta rather than Spark read.format delta. Okay, so yeah, nice addition. As if I was not myself, well, I just found this quite interesting that I'm noted in credits. Yet, to be honest, no idea how I contributed to this release. But anyway, thank you for including my name. Yeah, as I mentioned already, Delta Lake 080 release requires Spark 301. It's included in the POM, so it's as a Spark version, so 301. This is what they test Delta Lake with. But note that Spark release 302 has just been released 6 days ago, almost like yesterday again. But it's supposed to be backward compatible. As you noticed, I've been using 311 without much pain or failures or many failures. if at all, no failures yet, except there was one error message, which, by the way, I haven't seen, um, um, when I started our conversation. It was about something about Untitled parser, something about me using Spark 3.1.1 release candidate 3, which probably comes with latest version of Untitled parser for SQL, while Delta Lake expects something lower. And there was some, warning from Untitled that these, files or files compiled for, there are files compiled for different versions, something like this. Okay, it was just while I was preparing for the meetup. Okay. Yeah, there is this Metastore support, so data tables can be registered in a Metastore as high-level Spark native tables, or alongside high-level Spark native tables. There is support for SQL DDLs like create table, alter table, insert into, delete, something that you asked already, update, merge into. Okay, so something that you may have found in relational databases. Postgres was mentioned. Now you've got it available in Spark 2, thanks to Delta Lake. Okay. Beside this SQL known statements like create, alter, insert, delete, update, merge into, there are some Delta Lake specific SQL commands. Among them are convert to Delta, which is to convert Parquet table to a Delta table. So you can just have your existing Parquet table and have it converted to Delta Lake and tap benefits from versioning available in Delta Lake. Then you've got describe detail to describe your table by path or just identifier. Describe history. We'll get to it in a sec. Generate, to generate something that's helpful for Hive and Redshift, if I'm not mistaken, and also for Presto. I'm not really sure I'm touching the correct ground with this, but I know that this is for to interoperate with other tools. Vacuum, to clean up files that are no longer needed for our Delta table to function properly. Okay, these are extension SQL commands that you may only find in Delta Lake. They are not available in other SQL environments. Okay, so demo 2. We've got half an hour, if I'm not mistaken, still. So in this demo, you will learn how to use these SQL DDLs and DMLs with Delta Lake, like create table, describe extended, insert into, describe detail, and describe history. And you know what? Every time when I'm touching SQL itself as the language, I'm a little bit uneasy with what's coming because I'm not SQL heavy user. I just developed my understanding of SQL and how to use SQL using, Spark SQL, and by reading all the documentation, all the source code, all the tests, and as well as by looking at or following Delta Lake. So if you ask me, hey, could you type join in SQL? I would say no. That's way too much for my SQL skills. Well, I probably managed to do so, but anyway, that's the fear I've always been experiencing while speaking about SQL, pure SQL. But I know how important it is that Delta Lake and Spark SQL support both support SQL, the language, structured query language, or SQL, as some say. Yeah, it's important because it just opens the doors to this big data distributed computations for people who are SQL heavy or savvy, rather than being a programmer, Python, Scala or Java. Okay, same with Python. It's important to let them use Spark for something that they thought is possible, has always been possible with, for example, Pandas or NumPy. Okay, so let's dive in to SQL support in Delta Lake. Okie doke. So let me switch. And again, this is streaming query is still up and running. So I have not stopped it yet. So all the changes to our table are going to be reflected by this streaming query. Okay, so first query you may execute in your SQL environment is show tables, right? You want to see and truncate, just to be explicit, what this false stands for. And so let me just zoom in, and oh, that's exactly the exception, because well, now we are dealing with this parsing of this SQL expression. So that's where Untitled comes on stage and is used. So yeah, but after this, look at this, you will see no warning. So this is just for the very first time, and that's it. So anyway, so that might be the reason why you should not use Spark 3.1.1 with Delta Lake 0.8, and you should expect 0.9 soon, or 0.8.1, just to clear things up. Okay, so no tables. Okay, let's have a look if there are any tables registered in Spark catalog by using, well, by using this API, show false. It's basically the same, okay, but gives you some extra information that you may only find in Spark native catalog, okay, other than using this show tables. Okay, so now let me create a table. I'm copying this command. Yeah, so create or replace table D01 with two columns, ID and name. And this is very important, using delta. Otherwise, we would create this table with using Parquet format, which is the default. By the way, you could change this default format to Parquet, to delta. There is this configuration option. So rather than repeating this using delta, or just not even telling people that you change the default format, they would probably notice nothing different if you switch this default format from Parquet to Delta, except that you are adding something that they may eventually like and awards you eventually too. So end with this comment, okay? So create brand new table. And now when you do show tables, and yeah, show tables, you see this table created, okay? And what's in this Spark catalog? Well, you've got this too, but the difference is that you see this comment that was added by using this comment. I'm not sure if you can show tables to the point to get this. No idea. Okay, if you know, let me know. Okay, so now what I'm gonna do is I'm gonna register a new table, but not by using SQL language, but by saving as table using Scala API for Spark SQL. So Spark range, basic stuff. we are writing 5 record data set using format delta as a table D02 hub. So now we've got 3 tables. One is outside catalog in this TMP delta 01 directory, and 2 are registered in catalog. Well, they are regular tables, okay? And they are available in Metastore. So let's do this list tables. And we've got this these 2 tables, D01, D02. We see no TMP delta 01 because, well, it was created differently without using catalog. Okay. And then we can also create table without catalog using SQL by using this weird looking identifier, table identifier. So Delta Lake supports this. Well, it's not Delta Lake, by the way, because it's supported by Spark SQL itself. Yeah. So you can just specify your format. And so you can just say create or replace table, and you can specify a format, but I'm now thinking whether specifying this using Delta instruct Spark SQL to ask Delta first. Okay, this interaction is not clear to me yet, but definitely you can specify Parquet with some custom path too by using this backticks. Okay, anyway, so create or replace table, and you specify this directory location by using this backtick notation with this extra, with this columns, ID and name, and using table, using delta. Sorry, too many data sets, data frames, delta lake, data lakes, and oh my, all these. Okay, so now let's see what we have in list tables. There should be no change compared to what we saw previously, because, well, by doing this, we said skip catalog. We want to have it in this directory rather than something that's managed by Spark and registered in catalog. I'm not very familiar with Hive Metastore or Hive Metastore-like things. When I started exploring, Spark and Delta Lake, Hive and MapReduce were all at full swing, and people have been were using these tools very heavily. I had not at the time, and since then I had no time for them. So, well, yeah, so I built all my understanding about this Hive Metastore-like things by looking at Spark SQL and Spark SQL-like solutions, including Delta Lake. So I apologize if I'm describing things, easy things, a little bit harder than usually is. Okay, so create or replace table does not register tables in catalog. Okay, okay. Now, let's do this. Show tables again, show tables, and show false. Yeah, we see exactly these two tables. So D01, D02, fine. But what I wanted to show you is this describe extended SQL command that Delta Lake supports. So describe extended, and you have all this information about Delta Lake table named D01. So you've got information about columns, whether or not it's partitioned, and some extra information that Delta Lake provides at save time. Okay, so database, name of the table, some extra comment. I managed to find how to add location. This is under this Spark warehouse. It could also be in Hive Metastore. provider, Delta, and some extra information for Delta to read this properly. Okay, or let other read this properly. Okay, now let's read table D02 using table related or table focused command, which is, well, operation, which is Spark table, rather than what we did previously, Spark read, format, Delta, and then load, and then blah, 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 you know, TMP, whatever. Let me make sure that it's not going to be executed. So yeah, first of all, we've got no idea where this D02 is stored, actually. So, and it does not really, it should not really bother us, okay? So, well, that's kind of like alias for our location, which I found quite interesting and quite useful. Otherwise, well, so you basically have no idea what to specify as load to touch this D02 table. You could query for this information by describe details and or this describe extended, and then you'd have to you'd figure out what's the location, but you might not even have access to this storage location. Okay, so Spark table, just basically it. Okay, it's all supported in Delta Lake. Okay, good. Now, what I found really interesting is that this works too. Yeah. Okay. So hold on. Let me repeat. This one. Let me do this. This one is just something that you may have used with other tables, but this is brand new to me. I did not know, and I'm glad that I'm presenting all this. I'm presenting Delta Lake on meetups like yours, like this, because I can focus on things that I'm gonna show and that work, and sometimes discover things I didn't even imagine might be possible. And one thing is that this is supported, and probably it's because this extension, not Spark SQL, Spark session extension, but because of this catalog that understands table identifiers of this shape, where this is data source and this is path. Not sure if it's Delta Lake specific or is it Spark SQL specific, but definitely it works in Delta Lake too. So very cool, very nice. So if you are working with directory-based Delta tables, well, you can just use Spark table too. Okay, nice. Okay, so now we are going to insert some new records that should trigger. That's where I'm gonna show you this. That should trigger because we are inserting into this Delta TMP Delta 01, and which this streaming query monitors or keeps watching. So, oops, sorry, that was not what I meant to do. Okay, so Control K and hop. And soon you will see batch 32 with this information, with this rows that were part of this data set. Okay, so we insert into, we use something that's table specific, usually for tables that are registered in Metastore, Metastore, maybe in catalog is fine to say too, no idea, but definitely it works with Delta Lake using this weird looking table identifier. Okay, And okay, so delete from, finally, right? We are 15 minutes before we finish our meetup, so please keep your questions coming so I can just answer them in a sec, okay? So Spark table, and we can just delta, and why am I doing this? Okay, so I'm gonna delete from, and I'm gonna look at this, what I did. I'm gonna find out what's the maximum ID in my delta table. Why? Because I'm gonna wipe it out completely, okay? Well, except one record, the maximum record, okay? So what I'm doing now, I'm executing a batch query over my delta table to compute maximum of ID, which now I'm using for delete from. And now 26. Well, yeah, I know that I could just collect and get this 126 to be automatically added here, but I meant to do this more interactively, okay? So I got this 126 and I remove everything, every record. I'm deleting records with ID less than 126, leaving just one record, the one with ID 126. So, bah. Yep, done. No changes here. I think, no, it was not with delete, if I'm not mistaken. It was when schema changed, but the very first time I tried this, I hoped, in a sense, that I expected this streaming query fail because, well, this information in this delta table changed since this streaming query had started. Yet, why would it bother this streaming query anyway? But this is me thinking aloud. So it was okay. This streaming query still works fine. Reporting, checking offsets every 5 seconds. And now let's describe this table and see more details about this table. We just deleted 126 records from. Okay, so first of all, this is described detail about this table. These are all the information that you may ever get from Delta Lake and Spark SQL about this Delta table. Okay, so what's the format? What's the ID? This is the ID that we saw in the logs. Name, you can give this table a name, if I'm not mistaken. This is something I'm not really sure about. Description, location, created at, last modified, partition columns, no columns, number of files for this version, latest version, size in bytes, some other properties, and mean reader version and mean writer version, just making sure that older versions have no access to our Delta table, especially for readers and writers without support for features that this Delta table could use. Okay, so this is just to make sure that you are backward compatible across your readers or with your readers and writers. Okay, so this is described detail of our table. And now let's describe our history. So another SQL command supported by Delta Lake, describe history, where you see all the history, all the entries that constitute history of past operations, transactions that modified one way or the other our Delta table. So we know that the last command operation was delete. One before was write, batch write, batch write, batch write. This is streaming update. So operations have names. There are some operation parameters that you may just query and for some monitoring purposes. Some other information. User metadata, you can just specify user metadata using user metadata option. So you can just mark some transactions special. So you can just query history by looking up entries with user metadata of given shape or given value. It might be much beneficial for your reporting purposes. Okay, and all this is just basically another view, another perspective at JSON files. This is exactly what you may have figured yourself by looking at JSON files directly. Okay, good. So we've got 7 minutes before we finish, and that's basically it as far as this demo is concerned. So let me see what's coming. Aha! Ladies and gentlemen, I'm glad that this is exactly the moment. Oh, this is the slide because I was worried that time traveling might not be covered, which would be not good. Okay, so time travel by version of time or timestamp. As you know, Delta Lake tables are versioned, so they can get accessed by version or timestamp. Versions could get created. So I'm more familiar with versions because timestamp, creating timestamp is just boring and tiresome and yeah, so, whatnot. So it's just basically simpler accessing tables by version. But know that timestamp is also possible. Scala, Java, and Python APIs all support this version as of option, as well as timestamp as of option. So you just specify either number that denotes the version you want to access, or by timestamp. Okay. Unfortunately, no support for these options in SQL, pure SQL. It's available in Databricks. Sorry to say it. Hope you don't mind me blaming Databricks not open sourcing this very cool feature. As I said during my previous meetup, I wish Databricks focus more on integrating Delta Lake with the platform, with Redis too, and making sure that Databricks platform is stronger, better, not by stripping down Delta Lake, but by focusing on something else. But hey, that's how it is. So no Z-index, no SQL support for version as of or timestamp as of. Sorry. What we do have available in open source Delta Lake is table identifiers path with time travel. So by specifying this at v with version or at timestamp, you may access particular version of table by specifying this table identifier, which is a path to your Delta table. Okay, so that's pretty cool that this is available. And well, that might be the reason. Oh, I might be mistaken if it is possible to access Delta Lake tables using SQL with this time travel. Ooh, we'll see. What's new in 0.8 is that you can start streaming a table from a specific version. So you've got two new options: starting version, starting timestamp. And so now you're basically specifying these options, and you can just start from this table. Why did they not leverage version as of for this starting version? Okay, have to ask them. So yeah, that's definitely possible. So let's have a look. We've got 3 minutes before we finish. So let me show you very quickly how to use versions. So we know that we've got this SQL API to show versions of our Delta table, but we can also do something like this. IO Delta and tables and Delta DT. Yep. Did you know that you can autocomplete in Spark Shell by DT just by this titles? Oh, now it's not gonna work. Okay, let me check again. No, okay. So just for the very first time it works, then it stops working. So Delta table, and now you do something like this. You access this Delta table using this Delta table programmatic API, and you specify that you are going to access Delta table by path, which is TMP Delta 01. It's also possible for Python, but I just started with Python, so I'm not even going to show you this in the other language. And DT history will give you history as a data frame, so you can just show truncate false, and you will get all the goodies that you have seen in SQL or using SQL, right? So you've got this delete being the last operation. Nice. So now let's describe history. So this was the one way. There is describe history delta this way. It gives us the same information. So you've got this and this. Yep, both work same. Okay, so now let me time travel using version as of option using Spark SQL. So this is batch query. So what I'm gonna do is, yeah, I just copied it. I'm gonna read version 0 of my table, even though I'm at around 30th version. Now I'm gonna access 0th version. Is it possible? Yeah, it is. So 2 records only. What if I specify version 5, for example, or 5th? Oh, you've got something different. If we want to access the latest version, well, we just skip this and we are done. Right? Right. So as you can see, this is the beauty of Delta Lake, which gives you access to all the versions that are available in transaction log. So unless you vacuum some versions, so they are no longer available, you can just time travel back and forth between versions and just compare them for various reasons. Okay. You may also do something like, calculating maximum version by querying this desk history Delta table, but hey, you don't need to calculate it because by default, you are accessing the latest version. You can also time travel by this table identifier, which is something that I just discovered. And so by this at v0, you are accessing 0th version, initial version of your Delta table that's available at this path. So show, that's basically what you've seen. So this is same like this. Yep, the same. And something that I wanted to share, wanted to check, I'm not sure whether it's gonna work or not. Let me see if I can select stuff from this. That'd be cool. This is something I've got no idea whether it's gonna work or not. Geez, that works. So maybe I'm wrong saying no support for SQL, because that's exactly what I meant by saying no support for SQL. Sorry guys, need to change the slides. Yeah, that's me. So yep, so that might not be true no more. Okay, and that's pretty much it, guys, folks. Where is this? okay, anyway, I need to find a way how to just write about, just cross it out. Okay, so let me switch to this and finish our presentation. So, ladies and gentlemen, all what I covered, you can pretty much find in this excellent book, Learning Spark, in chapter 9, building reliable data lakes with Apache Spark. You can find more interesting information than what I just covered. Might not necessarily be that low level, yet they are very entertaining too. There are also competitors covered, Hoodie and Iceberg. It's written, the book and the chapter is written by Jules Brook, TD, which is the main author or one of the authors, creators of Delta Lake and Spark Streaming and Spark Success Streaming. And the last but not least, the only Danny Lee, okay, my mentor these days. Thank you, Danny, for sticking to all my questions and being so patient. Okay, so what else? You've got this VLDB paper, which honestly I haven't read yet. It's on my shelf, reading shelf. Looks like this is something that should solidify your understanding how, where, and when to use Delta Lake properly, because it's basically describes motivation, ideas, and design of Delta Lake, and it's written by the brains who created Delta Lake, Michael, TD, and others, Burak, yeah. Okay, and it's free of charge, so basically it costs you just your time. And yeah, the last but not least, there is this book free of charge of mine, Internals of Delta Lake. I try to keep it up to date. So now I'm focusing on 08, but as you may have heard a few times during this presentation, I'm not that fully up to speed with all the changes in 08 yet. So I'm working on it. So next time we meet, I might be more ready. Yeah, definitely. That's all, folks. Thank you. What are your questions?
Yes, yeah. Thank you for your presentation. It was great.
Awesome. Thank you. Pleasure is all mine, definitely. Should I answer all the questions left?
We are over time, so let's do the following. So let's please answer the questions, or you can get it and we can email them after the call. But if you have time, like 5 more minutes, you can give the answers. Then we can close the call.
Sure. Okay, so I'll answer questions using this Q&A panel. And yeah, if you've got any other questions, just drop me an email at Jacek@yapila.pl or just DM at Twitter at Jacek Laskowski. So I'm open for conversations about Delta Lake, Spark, and Kafka. Okay, thank you.
Thank you so much joining us, and thank you for your presentation, Jacek. It was great, like I said. So I wish you a great day.
Thank you so much. Pleasure was definitely all mine. Cheers. Bye.
Cheers. Bye. Take care.
Take care.